Hey guys, so here is part 2 of the section 3 day 1 notes. We are going to be talking about how to solve absolute value inequalities. Now when we do this, we're going to solve absolute value inequalities, then we're going to graph our solution on a number line, and then write our final answer in interval notation. Okay, so we have two types here. We have where it's the absolute value of ax plus b is less than c. Now this could also be less than or equal to, okay? This is what we call the and problem because it's less than. Now, when we solve these, we are going to write a compound inequality. There we go. And so what's going to happen is that we're going to have what's inside the absolute value bars in the middle, and then our c value, we will have positive on the right, and then the negative value on the left there, okay? Okay, let me write this a little bit better. There we go. Now, you'll see when we actually graph these on the number line, because we're graphing in between two numbers, we're going to shade in between them. Okay, now let's talk about the other one. We have absolute value of ax plus b is greater than c. This can also be represented as greater than or equal to, okay? These are what we call the or problems, okay, greater. So we either have ax plus b is greater than c, or ax plus b is less than negative c. So we don't really write it as a compound inequality. We create two of these inequalities separate, okay? Now for this, you'll see basically that we're going to shade on opposite directions. And the reason we do this when we shade opposite directions is because with the or, we really only have to satisfy one, or any number that we plug into our absolute value inequality, it only needs to satisfy one of the inequalities. While with the and problems, when we plug in a number in for x, it has to satisfy both conditions, okay? We're going to go ahead and try a problem here. Okay, here it says solve the following inequality, graph your solution on the number line, and write your answer in interval notation. Okay, so we have to create two inequalities. Now notice what this is. We have a less than 3, so absolute value of x is less than 3. What I like to do is indicate is this an and or an or problem. Well, this is a less than, so this is an and problem, meaning we're going to create our compound inequality. So I have x in the middle. Notice I got rid of the absolute value bars, just like we do with absolute value equations when solving. Then I have my less than 3, because that's my positive side, but I also have to have the negative 3, so that's going to be less than x, okay? Now usually from here we would solve, but there's nothing else with the x, so this would be basically our final answer here for solving, okay? Now our next thing that we want to do is create a number line. Now when you do your number line, it doesn't have to be this extensive, no. Really you want to make sure is you have these two numbers, like the negative 3 and 3, and probably 0 in between, okay? So now what we're going to do is put our circles. Now we're going to go back to piecewise functions, okay, when we talked about circles. When we don't have an equal bar, remember we had an open circle. That's going to be the same thing here as well with our inequality. Since we don't have equal bars, we're going to have open circles on negative 3 and 3. Okay. Now basically what we're trying to think of is we have to put numbers inside x. And those numbers have to satisfy both the negative 3 and 3. They have to be between negative 3 and 3. So those numbers can be like negative 2, negative 1, 0, 1, 2, any of those that we plug into here, they will be between negative 3 and 3. Other numbers like negative 4, well, we know negative 4 is not greater than negative 3, so that wouldn't work. Or like positive 4, well, 4 is not less than 3, so that wouldn't work. So that's why with and problems, we're going to shade in between, because it has to satisfy both of those numbers or those inequalities there, okay? Now our last thing we have to do is write our final answer in interval notation. So this is also going to be very similar to what we've done before, especially with parentheses and brackets. Okay, since we have open circles, we're going to use parentheses. Notice we have a starting position of -3, and then we go to 3. And we use parentheses because we have open circles. Okay, let's go ahead and do the next one. Okay, we have, once again, we're going to do the same thing. We have absolute value of x minus 2 is greater than 2. Notice this is greater. So it's an OR problem. Okay. So here I'm going to create two separate inequalities of x is minus 2 is greater than 2, or x minus 2 is less than -2. For both of these, I add 2 to both sides. So this is saying x is greater than 4, or x can be less than 0. So just like before, we're going to have to put circles on the 4 and the 0. And when we do this, notice we don't have an equal bar, so that means our circles are going to be open. So I have one at 0 and then one at 4. Okay. Now with ORs, that means the conditions can meet either one. Okay, so we can have basically where x is greater than 4. That means when we shade, we want to shade to the right because we want numbers. Oh no, we want numbers that are bigger than 4. Okay, so I'm basically following what it's telling me to shade. Okay, now the next one, it says x is less than 0. Well, that means I want to shade anything that is smaller than 0. There we go. Okay. Now our last thing we're going to do is write this in interval notation. Now reading this number line left to right, notice that this is going to go on forever. I know I stopped it at 6, but really it's going to go on forever. And it's going on forever in the negative direction. So what I'm going to use first is negative infinity. And remember, anytime we have infinity, we use parentheses. Now I come to a stopping point at 0 because I have a circle there. So I'm going to use 0. Now, just like the last problem, since it's an open circle, we use parentheses. Now we have a second part to this. So I'm going to use, once again, parentheses. I start back up at 4, and then that is shaded on forever to the right-hand side, which is represented with infinity. Now, our last thing that we need to put is what we call the union sign. This just kind of puts two or more things together, saying that we have negative infinity to 0 or 4 to infinity. Okay, so it's just putting everything together. So please do not forget to have this union sign when you're writing the interval notation of OR problems. Okay, let's go ahead. Let's go to the next one. Okay, what I would like you guys to go ahead and do is pause the video and try this one on your own. Okay, let's see how you did. So let's look at this. We have the absolute value of 2x minus 6 is less than 4. So this is an and problem because it's less than. So when we write this, we need to write it as a compound inequality. So we have less than or equal to 4, but then also greater than or equal to -4. Now we solve. So I add 6 to both sides. And then I get 2x. Still in the middle. So -4 plus 6 gives us 2, and 4 plus 6 gives us 10. I divide everything by 2. And so now I get x is greater than or equal to 1, but less than or equal to 5. Okay, now let's put this. So now notice we have equal bars, so I am going to have solid circles at 1 and at 5. Once again, your number line does not need to be as extensive as what I have. If you just want to put 1 and 5 and leave some room in between to kind of indicate like there's 2, 3, and 4, that's all right. Okay, so this is saying that we need numbers that are in between 1 and 4. That's basically 2, 3, 4, and everything else. So I'm going to shade in between. Now, writing the interval notation. Now that I have closed circles, I'm going to use brackets. Okay, I start at 1. And then I go to 5, and that's my stopping point. Okay, let's go ahead and do the next one. Once again, what I would like you to do is go ahead and pause the video and try this one on your own. Okay, let's see what you got here. Okay, Once again, we have a less than, so it's an and problem. So I need to make sure I create a compound inequality. -6. Okay, I subtract 5 from both sides. So I have x is greater than or equal to -11, and then less than or equal to 1. And that's a -x. Now notice we have a negative in front of the x. We got to get rid of that. How do you think we can do that? Hopefully you said that we can either divide or multiply by -1. I'm going to go ahead and divide. Now when we are doing this, I have room. Okay. Notice we are dividing by a negative. I hope you remember this. Anytime we are dividing or multiplying by a negative, we actually have to flip the signs. So the less than, I changed that. So I now have 11 is greater than or equal to x. And then I have x is greater than or equal to -1. Okay? So don't forget, anytime you multiply or divide by a negative, flip those signs. I'm going to rewrite this so that my smaller number is on the left-hand side. I just like the aesthetic of that. Okay. So it really just shows now that x has to be in between -1 and 11. So we do have equal bars. We have closed circles then at -1. And then this is going to go a little bit off the graph, but that's okay. And then at 11. So this is an and problem. We want numbers between -1 and 11. So I shade. And then our last thing we need to do is write an interval notation. So I start at -1. I use a bracket because I have closed circles. And then I end at 11. Okay. There we go. Okay, last thing we need to talk about are the special cases. So with the special cases, when we have already -c value, so when we have absolute value of ax plus b is less than or equal to -c, so these are and problems, what happens? Well, we say these are no solutions. The reason these are going to be no solutions is that if you did graph these, you would shade the opposite direction, but we can't do that with and, so it's just going to be no solution. With the other one, we have absolute value of ax plus b is greater than or equal to -c. With these type of problems, there are going to be infinitely many solutions. So how we're going to write that in interval notation is -infinity to +infinity. So make sure you do write it in interval notation. That's the most important thing. And so what happens is that we actually shade the entire number line. Okay. The reason this happens is that because they cross each other, and since it's or, we are able to use everything because everything works with it. Okay. Okay, if you have any questions, make sure you contact me. Make sure you work out the homework assignment so you understand this information. See you guys later.